Welcome to qnawire.
In this problem, we're going to talk about relativistic energy. So remember that the rest energy of a particle is 0 is equal to mc squared, and the total energy is equal to mc squared gamma. The kinetic energy is equal to the total energy minus the rest energy, and it's equal to mc squared times gamma minus 1. And in our problem, you have to suppose that you have a spaceship, and the spaceship has a mass of 2 times 10 to the 6th kilograms. And it's fueled by antimatter, and the mass of the fuel is 2 times 10 to the 4th kilograms, and half of this is matter, and half is antimatter. And when when the two interact, they are annihilated and produce energy. And our goal is to find what is the speed of the ship if all this mass is converted into kinetic energy for the ship. So notice that the ship is initially at rest, and the kinetic energy will be equal to mf c squared. But we know that the kinetic energy is the mass times c squared times gamma minus 1. So the c cancels out, and we have mf divided by m is equal to gamma minus 1. So gamma is mf over m minus 1. Mf over m is 2 times 10 to the 4th divided by 2 times 10 to the 6th, and actually there's a plus here, and that is 0.01. So gamma is 1.01. And since gamma is 1 over the square root of 1 minus v squared over c squared, then 1 minus v squared over c squared is equal to 1 over gamma squared, meaning that v is equal to the square root of 1 minus 1 over gamma squared times c. So v is equal to the square root of 1 minus 1 over 1.1 squared times c, and this is equal to 0.14 times the speed of light, which is our answer.